Hi, geometry students. Today we're going to talk about midpoints and segment bisectors. Segment midpoints and segment bisectors. So what is the midpoint? The midpoint of a segment is the point which divides a segment into two congruent parts. Remember, congruent parts are parts that have the same measurement. So a midpoint divides a segment into half. A midpoint divides a segment into two equal parts. A midpoint divides a segment into two congruent chunks. And here we have M as the midpoint. And the reason we know it is because we remember the scratch marks mean congruency. So these scratch marks being the same tell me that AM is congruent to MB. And therefore M is the midpoint of AB. Now, if we're given an algebraic expression for AM, and we're given an algebraic expression for MB, and we see that we're told that they're congruent, or we can be told that M's the midpoint, or we can be given the scratch marks, we can use our algebra skills, because we know that if these two chunks are congruent, we know that to be congruent means your measurements are equal. If your measurements are equal, then the algebraic expressions for those measurements will be equal. And we can get the x's on one side and the numbers on the other and solve for x. Once we have x, we can plug it into our original algebraic expressions to figure out the length of those segments. Notice we can also use our segment addition postulate to know that part plus part equals the whole. If we know this is 41 and this is 41, then the whole AB has to be the sum, 82. So pause and practice this problem on your own paper, and then press play for the solution. So here we're given scratch marks, so we know AM is congruent to MB. We have an algebraic expression for AM and an algebraic expression for MB. And again, you could always mark your diagram and write it right on your diagram as well. That's a great way to do it. Because we're given those scratch marks, we know AM is congruent to MB, and so the measurements are equal. And so the algebraic expressions for their measurements are equal, so we can solve for x. Once we have x, we can plug it in to figure out the length of each chunk, and it's a good check step to plug it in and make sure they are the same, because we were given that they should be the same. And if we plug in, it's a good check step. And now to find the whole, we know segment addition postulate, part plus part equals the whole, AM plus MB equals AB. And so we can add them together to get AB as 42. Here's another practice problem. Be careful and look carefully at what you're given. So pause, practice on your own paper, and then press play. So we're given slightly different information in this case, but we're going to use the same concepts to figure it out. We know that AM and MB are congruent, which means their measurements are equal. In this case, we're only given the measurement for AM, and we're given an algebraic expression for the whole. So we know that if we're given AM is 12, we could mark it right on here, it's 12. And because this is congruent, this segment is congruent to this, that means their measurements are the same. So I know that has to also be 12, which means the whole segment, using segment addition postulate, part plus part equals the whole, that means AB has to be 24. And I'm told that the algebraic expression for AB is 4x minus 36, so I can set up my equation that way. And now I can do my inverse operations to solve for x, add 36 to both sides, and divide by 4. Once I have x, I could always plug it in, but I was given 12, 12, 24. So here is another chance to practice. Pause, the video, practice this on your own paper, and then press play for the solution. And always let me know if you have any questions. Okay, the last thing we're going to talk about in this video is what is a segment bisector. A segment bisector is anything that goes through the midpoint of a segment. In other words, anything that cuts a segment into two congruent parts. And listen, anything that goes through a midpoint of a segment is a bisector. So you could have a point, a line, a ray, another segment. Anything that cuts through the midpoint of another segment is called a segment bisector. So in this case, because of these congruent marks, we see AB is congruent to BC. That means AC is being split into two congruent parts, and B is the midpoint. So you could say B is the midpoint, so B bisects AC, or you could say line L bisects. So line L is the bisector of segment AC. So name the segment bisector in this diagram. Notice, because of these scratch marks, that tells me AM is congruent to MB, which means M is the midpoint of AB, which means XY is the bisector. Notice, XY is bisecting AB, but notice AB is not bisecting XY. So AB is not a bisector. AB is getting bisected, it's the victim. So pause, and on your own paper, jot down who the bisector is in this diagram. So because of these scratch marks, we see FA and AC are congruent, which means A is the midpoint of FC. There are lots of correct answers. You could have said segment AB is a bisector, segment BD is a bisector of FC, BE, any of those would be correct answers. I wrote that EB is the bisector, segment bisector, and it is bisecting FC. Notice FC is not a bisector. It's getting bisected, but it's not a bisector. The only bisector is this guy. Pause, write down the name of the bisector on your paper, and then press play. So in this case, we see these marks tell us that AM is congruent to MB, so M is the midpoint of AB, and so anything that goes through M will be the bisector. You could have said M, you could have said segment DM, segment MC, segment DC, or you could have said line CD, which is what I went for. So line CD is a segment bisector, CD is bisecting segment AB. And that is it for this video. So I will leave you with this cute puppy, and have a nice day.